Both New Jersey's Rehab Code and Massachusetts Rule 3 permit modifications to existing electrical installations that do not meet current code standards without requiring a complete system upgrade. New Jersey's Rehab Code is detailed in the New Jersey Administrative Code at NJ AC 5.23-2.20. It stipulates that additions or modifications to an existing installation must comply with the current code, but it does not mandate that the entire installation be brought up to current code standards. However, the modifications must not introduce any new code violations, nor can they exacerbate any existing violations. Massachusetts Rule 3, outlined in the Massachusetts Electrical Code at 250 CMR 12.0, mirrors this provision. It states that additions or modifications to an existing installation must adhere to the current code, but it does not require the remaining parts of the installation to be brought into full compliance. Similar to New Jersey's code, the modifications must not create any new code violations or increase the severity of existing ones. These codes are important because they enable the repair and maintenance of existing electrical systems without the often substantial expense and disruption of bringing the entire installation into compliance with the latest code requirements. This approach offers several advantages. Firstly, it allows for cost-effective repairs. Requiring full compliance with every modification could make even minor repairs prohibitively expensive, discouraging necessary maintenance and potentially leading to unsafe conditions. Secondly, it minimizes disruption. Bringing an entire electrical system up to code can be a time-consuming and disruptive process, particularly in occupied buildings. These rules allow for targeted upgrades that address specific issues without causing widespread inconvenience. Thirdly, it promotes safety. By allowing for repairs and modifications without requiring full compliance, these rules help ensure that existing electrical systems are maintained in a safe and functional condition. Neglecting necessary repairs due to cost or disruption could lead to hazardous situations. It is crucial to understand the limitations of these provisions. While they allow for modifications without full compliance, they do not permit the creation of new code violations or the worsening of existing ones. This means that any modification must be carefully designed and installed to ensure that it meets current safety standards and does not compromise the integrity of the existing electrical system. When undertaking any electrical work, it is essential to consult with a qualified and licensed electrician who is familiar with the local codes and regulations. The electrician can assess the existing installation, identify any code violations, and recommend appropriate solutions that comply with both the current code and the applicable rehab or modification rules. They can also ensure that the modifications are performed safely and in accordance with all applicable standards. Some examples of scenarios where these rules might apply include adding a new circuit to an existing panel board, replacing a damaged receptacle, or upgrading the lighting in a room. In each of these cases, the electrician would need to ensure that the new work complies with the current code, but they would not necessarily be required to bring the entire electrical system up to code. However, they would need to ensure that the new work does not create any new code violations or increase the severity of any existing ones. For example, if the existing panel board is undersized, the electrician would not be allowed to add a new circuit that would overload the panel. Or, if the existing wiring is not properly grounded, the electrician would need to correct the grounding issue before adding a new receptacle. In addition to the general requirements outlined above, there may be specific requirements that apply to certain types of electrical work. For example, there may be specific requirements for installing ground fault circuit interrupters, arc fault circuit interrupters, or surge protective devices. It is important to consult with a qualified electrician to ensure that all applicable requirements are met. The National Electrical Code, or NEC, is a widely adopted standard for electrical installations in the United States. While the NEC is not law in itself, it is often adopted by state and local jurisdictions as the basis for their electrical codes. The NEC is updated every 3 years, and each edition includes numerous changes and revisions. It is important to stay up to date on the latest edition of the NEC to ensure that all electrical work is performed in accordance with current standards. Some key areas covered by the NEC include wiring methods, overcurrent protection, grounding and bonding, and equipment installation. The NEC also includes specific requirements for different types of occupancies, such as residential, commercial, and industrial buildings. When performing electrical work, it is essential to follow the NEC guidelines to ensure safety and compliance. Grounding and bonding are critical aspects of electrical safety. Grounding provides a path for fault current to return to the source, which helps to trip the overcurrent protective device and to energize the circuit. Bonding connects all metal parts of an electrical system together to create a low impedance path for fault current. Proper grounding and bonding can help to prevent electrical shock and fire hazards. Overcurrent protection is another essential element of electrical safety. Overcurrent protective devices, such as circuit breakers and fuses, are designed to interrupt the flow of current when it exceeds a safe level. This helps to protect wiring and equipment from damage and prevent electrical fires. It is important to select the appropriate overcurrent protective device for each circuit based on the ampacity of the wiring and the load it serves. Wiring methods are also crucial for electrical safety. The NEC specifies different wiring methods for different applications based on factors such as the environment, the type of occupancy, and the voltage level. Some common wiring methods include non-metallic sheath cable, armored cable, and rigid metal conduit. It is important to select the appropriate wiring method for each application to ensure that the wiring is protected from damage and that it meets all applicable safety standards. Equipment installation is another important aspect of electrical safety. The NEC includes specific requirements for installing different types of electrical equipment, such as panel boards, transformers, and motors. It is important to follow the NEC guidelines when installing electrical equipment to ensure that it is properly grounded, protected from overcurrent, and that it meets all applicable safety standards. In addition to the NEC, there may be other applicable standards and regulations that apply to electrical work. For example, the National Fire Protection Association, or NFPA, publishes a number of standards related to electrical safety, such as NFPA 70E, which covers electrical safety in the workplace. It is important to be familiar with all applicable standards and regulations before performing any electrical work. Proper planning is essential for any electrical project. Before starting work, it is important to assess the existing electrical system, identify any code violations, and develop a detailed plan for the modifications. The plan should include a list of all materials and equipment needed, as well as a schedule for the work. It is also important to obtain any necessary permits before starting work. Safety should always be the top priority when performing electrical work. Before starting work, it is important to energize the circuit and verify that it is dead using a voltage tester. It is also important to wear appropriate personal protective equipment, such as safety glasses, gloves, and insulated tools. Never work on live electrical equipment unless you are properly trained and equipped. It is also important to be aware of the potential hazards associated with electricity, such as electrical shock, arc flash, and arc blast. Take precautions to avoid these hazards and to protect yourself from injury. In addition to technical knowledge, it is also important to have good communication skills when performing electrical work. It is important to be able to communicate effectively with clients, contractors, and other members of the team. It is also important to be able to explain technical concepts in a clear and concise manner. Continuing education is essential for staying up to date on the latest electrical codes, standards, and technologies. The electrical industry is constantly evolving, and it is important to keep learning to stay ahead of the curve. There are many opportunities for continuing education, such as online courses, workshops, and conferences. Investing in continuing education can help you to improve your skills and knowledge, and it can also help you to advance your career. The use of technology is becoming increasingly important in the electrical industry. There are many software tools available that can help with tasks such as circuit design, load calculation, and energy analysis. There are also many mobile apps that can be used to access electrical codes, standards, and other information. Learning how to use these technologies can help you to work more efficiently and effectively. Firstly, understanding the scope of work is crucial. Before beginning any electrical modification, it's essential to clearly define the project's boundaries. What specific circuits or components are being altered? What are the existing conditions, and what are the desired outcomes? Secondly, conduct a thorough inspection. Evaluate the existing electrical system to identify any pre-existing code violations or potential safety hazards. This includes checking wiring, grounding, overcurrent protection, and the overall condition of the equipment. Thirdly, determine the applicable codes and standards. Identify the relevant electrical codes and standards that govern the project. This typically includes the National Electrical Code, as well as any local or state amendments. Fourthly, develop a detailed plan. Create a comprehensive plan that outlines the scope of work, the materials to be used, the installation methods, and the safety precautions to be taken. The plan should also address any potential code compliance issues and provide solutions to resolve them. Fifthly, obtain necessary permits. Depending on the scope of the project and local regulations, it may be necessary to obtain electrical permits before starting work. Ensure that all required permits are obtained and that the work is inspected by a qualified electrical inspector. Sixthly, implement safety measures. Prioritize safety throughout the project. Energize circuits before working on them, use appropriate personal protective equipment, and follow safe work practices. Seventhly, perform the modifications. Execute the electrical modifications according to the plan and in compliance with all applicable codes and standards. Eighthly, test and verify. After completing the modifications, thoroughly test and verify the electrical system to ensure that it is functioning properly and that it meets all safety requirements. Ninthly, document the work. Maintain detailed records of the electrical modifications, including the scope of work, the materials used, the installation methods, and the test results. Tenthly, follow up and maintain. Periodically inspect and maintain the electrical system to ensure that it continues to operate safely and efficiently. Address any issues promptly to prevent potential problems. The goal is to ensure the safety and functionality of electrical systems while allowing for practical and cost-effective modifications. Always prioritize safety and compliance with applicable codes and standards. Remember that electrical work can be dangerous, and it should only be performed by qualified and licensed electricians. These codes recognize that requiring full code compliance for every minor alteration can create unnecessary financial burdens and discourage homeowners and businesses from making necessary repairs. By allowing for modifications without triggering a complete system overhaul, these rules aim to strike a balance between safety and practicality. Understanding the specific requirements and limitations of these provisions is essential for anyone undertaking electrical work in Massachusetts and New Jersey. Consulting with a qualified electrician is crucial to ensure compliance and safety.